Dear students, today we need to discuss about Prim's and Kruskal algorithm. So, before going to see about Prim's and Kruskal, first of all, we need to know about what is algorithm. Algorithm is a step-by-step procedure for solving a particular problem. So, Prim's algorithm is a minimum spanning tree algorithm that takes a graph as input and find the subset of the edges of the graph which form a tree that includes every vertex. It has the minimum sum of weights among all the trees that can be formed from the graph. So Prim's spanning tree algorithm to find minimum cost spanning tree uses the greedy approach. Prim's algorithm has a similarity with the shortest path algorithms. Prim's algorithm, in contrast with Kruskal's algorithm, treats the nodes as a single tree and keeps on adding new nodes to the spanning tree from the graph. So consider we need to take it as totally 6 vertices in the graph. Name it as S, A, B, C, D, T. So here source vertex is S and destination vertex is. So first we need to see the step 1 is remove all the loops and parallel. So here loop is C to C is 1 and parallel edges A to B and B to A. So in this parallel edges we need to choose the highest weight. Okay, to choose the highest weight and remove the. So step 2 is remove all the loops and parallel edges from the given graph. In case of parallel edges, keep the one which has the least cost associated with remove all others. So here we will remove all the remove loops and parallels. So step 2, choose any arbitrary node as a root node. So in this case, we choose S node as the root node of Prim's spanning tree. This node is arbitrarily chosen, so any node can be the root node. So one may wonder why any video can be a root node. So the answer is in this spanning tree, all the nodes of a graph are included, and because it is connected, then there must be at least one edge which will join it to the tree. So in this step 3, from the source vertex, we need to find the adjacent of source vertex. So what are the adjacents of source vertex from S? So S2A and S2C. S2A cost is 7 and S2C cost is 8. So here we need to choose the minimum cost. So here I need to choose S2A is. So from the next step, we need to take again adjacent vertices of S and A. So in this, from A to C is 3, A to B is 6. So here we need to choose minimum count. So A to C is 3. So we need to choose next part as 3. We need to go D. From D to B and D to T is 2. So here we need to, so here our condition is we need to visit all the vertices exactly 1. So I need to choose D to B is next vertices. Again I need to take the adjacent vertices for A, C, D, B. So in this next minimum is weight is 2, so I need to choose D to T is 2. So whenever if I can choose the minimum cost edges, so in that time there is no loop will be. So if there is loop will be upper means we need to skip this. You need to choose the next minimum. So this is the final answer. So S to A 7 and A to C is 3 and C to D is 3 and D to B is 2 and D to T is 2. So totally 10, 3 plus 3 plus 2 plus 2. So 7 cost is 17. So next we need to discuss about Kruskal's spanning tree algorithm. It is used to find the minimum cost spanning tree uses the greedy approach. This algorithm treats the graph as a forest and every node it has an individual node. A tree connects to another only if it has the least cost among all available options and does not violate minimum spanning tree process. Next, how Kruskal algorithm works. It falls under a class of algorithms called greedy algorithms that find the local optimum in the hopes of finding the global optimum. We start from the edges with the lowest weight and keep adding edges until we reach our goal. So next steps to find the Kruskal algorithm. Sort all the edges from low weight to highest weight. If adding the edge created a cycle and reject the edge, keep adding edges until it reduces. So consider that this is an example for Kruskal algorithm. So here also first of this way we will remove the loops. So remove all the loops and the parallel edges. Remove all the loops and parallel edges from the given graph. So here A to B is 9 and C to C is 1. Okay, we will edges. So in case of parallel edges, keep the one which has the least cost associated and remove all the edges. So arrange all the edges in their increasing order of weight. So first we need to write the weights in increasing order. So here D to D is 2, D to T is 2, A to C is 3, C to D is 3, C to B is 4, B to D is 5, A to B is 6, S to A is 7, S to C is 8. So next we need to comment one by one. If there is any cycle is formed, means we need to skip that edges. So add the edges which has the least weightage. Now we start adding edges to the graph beginning from one which has the least weight. Throughout we shall keep checking that the spanning properties remain intact. In case by adding one is the spanning tree property does not hold, then we shall consider not to include the edge in the graph. So here the least cost is 2 and the edges node are DD and ET, so we add them. Add them does not violate spanning tree properties, so we continue to our next edge line. So next minimum edge is 3. So no cost, next cost is 3 and associated edges are A to C and C to D. We add them again. So A to C is 3 and E to C is 3. Now there is no cycle is formed, so we need to choose this. So next cost is 4. So we will observe the, so whenever if you are choosing C to B, it will form a cycle, so we will remove it and we need to see on the 6 is also forming a cycle and remove the edges from and finally we will go to node 8. So E2 is 7 and 8. We shall add the edges with cost 7. So this is the final answer.